Hello guys, welcome back. So today we are going to discuss what are the techniques you can use to memorize any formula that comes in Doppler effect. So first, what is Doppler effect? The change in frequency of a source, whatever it may be, whether it may be an ambulance or whatever the moving object which emits sound. When it is moving, there is a change, or even more precisely to tell, there is a shift in the frequency of the emitted frequency. So that is called Doppler effect. So now we are going to discuss what are the ways and techniques to memorize any type of case that comes in Doppler effect. So first of all, there is a simple formula that you all need to memorize, which is a formula that is a general formula for any case in Doppler effect. So Doppler effect. So what is the general formula? F dash equal to velocity of sound plus or minus velocity of medium plus or minus velocity of observer divided by velocity of sound plus or minus velocity of medium plus or minus velocity of source multiplied by the original frequency of the source. So what are the sign conventions? So let us take sign conventions. If the medium is in the direction of the source, then we will take positive for Vm. For example, wind is a medium generally. So if the source, this is source and its velocity, both the velocities are in the same direction, then we take Vm to be positive, and vice versa for the opposite case. This is case 1, case 2, wind, source, Vm to be taken negative. This is rule number 1. Rule number 2. What is rule number 2? For this rule, you need to have a little bit of imagination, because we are not going to memorize all the cases. So what is that thing in imagination? Suppose, imagine this is the road. Suppose you are standing here. Sorry, I'm not good at drawing. Suppose you are here. This is a car that's horning and moving with a velocity v. So this is our source. Here is our observer. So generally, what do you observe? When the car is approaching you, you will feel a increase in pitch of the car horn, and when it is right, it is exactly opposite to you, you will feel that the pitch has increased a lot. And when it is moving away from you, again you feel a decrease in the pitch of the sound in the horn. Decrease in the pitch of the horn. Sound and pitch are different. So according to the general formula, F dash equal to, as the frequency is going to increase, we are going to generally we will take the medium's velocity to be 0 in all the cases. If you want to put in any exam, if he gives that the medium's velocity is not 0, then you are going to use this sign conventions that is given in the first rule. So we'll take Vm equal to 0 for simplicity. V as the frequency, this is also called as apparent frequency. Apparent frequency is the frequency which is having a shift in from the original frequency. So as the apparent frequency is going to rise when an object is approaching you, we'll put a plus sign in the top, in the numerator. As you know, putting for example, take 1 by 1 divided. If you put plus 2 and minus, you take 3 plus 2, 3 minus 2. This is the thing. 3 plus 2, 5, 3 minus 2, 1. So from the original value you got an increased thing. 3 minus 2 by 3 plus 2. What did you get? 1 by 5, which is lesser than the original value 3. So the same principle we are going to apply here. V plus V naught. V naught is the velocity of observer. Okay, put it like that. We will take cases, no problem. V plus V naught by, as the thing is, as the source is approaching you, you are putting this thing V plus V naught. And as you know from this example, V minus Vs multiplied by F. Recalling again, F dash equal to V plus V naught, as it's there in the original formula, V plus V naught by V minus V velocity of source. So this gives the pitch which is increased from the real one, V plus V naught by V minus Vs. Okay, this is the case when the source is approaching you. Next, if the source is moving away from you, we notice it. So from the second example, you have to subtract. So it is V minus V naught. Sorry for the disturbance, guys, it's my neighbor's dog. V minus V naught by V plus Vs into F. You are going to subtract the observer's velocity from the original velocity, the speed of the sound speed divided by addition, sound's speed by source's speed. Next, this is case 2, case 1, case 2. What is this? This is approach. This is separation. Okay, you might ask, what if they both are stationary? Then it's very simple. Both are stationary. F dash from the original equation, V naught equal to 0, Vs equal to 0. So you will be getting V by V into F, which is nothing but F dash equal to F. So there is no change in the frequency. So there is no apparent frequency or anything like that. Okay. What are the cases where you get no Doppler effect? Cases in which Doppler effect can't exist. There are 3 different cases. So we are speaking of case 1. Case 1. Case 1 is when they both are stationary. Case 2. When their relative motions are equal. That is V naught equal to Vs. So what happens if V naught equal to Vs? Let us see. F dash equal to V plus or minus V naught by V plus or minus Vs equal to V naught. So V naught into F. So there is no change. So f dash equal to f. And case 3, when these both are perpendicular to each other or they are moving in a circle. Observer, and this is the source. When the source is moving tangentially, or the locus of the source is a circle, then you say that there is no Doppler effect, because the velocity is always in the direction tangential to the center. So you're not going to get any velocity in this direction or this direction. So there is no Doppler effect. So that's it for today, guys. I hope you understood Doppler effect and the way to memorize it. Thank you.